Welcome to Driven. I'm your host, Paul Perrone. We're going to learn and talk about AI, robotics, autonomous vehicles, and so much more. Check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. So kick back or buckle up and become driven. Steve, thank you so much for joining me today on this podcast. It's been a while since we probably last connected at one of the SAE on-road automated vehicle standards committees. I think they changed the name. So
Right, yeah, it's now on-road automated driving is the name of the committee now.
Excellent. Well, I know you're very busy on a lot of different activities, and I'd like to discuss all those. But I know you're busy as a research engineer at UC Berkeley, Institute of Transportation Studies. Is that the correct department?
Yes, it's in the Institute of Transportation Studies, the PATH program, where I've worked. I started working there in 1989, and I'm now semi-retired, so I only work part-time.
Excellent. Well, let's just start right out. Since you've been in the field since, I guess, the 80s, what's your take on where the industry thought we'd be back then versus where we are today, in your perspective?
Well, I actually started in the early 1970s. So I began when I was a graduate student in the early 70s. And of course, it's been a trend throughout the history. People have always had over-optimistic predictions. And I know I tell people that if I knew then that we would still be discussing most of this in the future tense 50 years hence, I would have gone into something else. Wouldn't have worked on this field because at that point we thought things were going to happen more quickly. And it's been that way ever since. People thought it was going to happen more quickly, and then it took longer. And it takes long because it's hard. And it's particularly hard when we're dealing with safety critical systems.
Right. I mean, yeah, and I've been in the industry for a little over 20 years. So, and I feel the hurt. So I can only imagine. And you've been a pioneer in the space, and I want to talk about some of the early things that you've done. But what do you think, like from your perspective, have been the hardest things about this that have made it kind of lead down this 50 or not 50, but multi-decade path of just not having autonomous vehicles or automated vehicles everywhere by this point?
Yeah. Well, I think it comes down to the complexity of the driving environment and the complexity of the driving task that people really underestimated. And it's important to think of this in terms of, I always think in terms of statistical distributions. We've got statistical distributions with really long tails. So there are very rare events that happen way out on the tails of the distribution, but those are safety critical events. And when you're designing the system has to be able to deal with all of them because human drivers deal with all of them right now. And if we're talking about trying to design a system that is no less safe than human drivers, it's got to be at least as safe. It needs to handle all of the things that human drivers handle all the time. And I think people have underestimated the complexity of that throughout the whole period of development on this. And that's why much of the earlier work was focused on limited access highways and more limited complexity driving environments. I also always remind people we have fully automated vehicles that have been carrying passengers for 50 years now. They're people movers in airports that run in protected rights of way from one terminal to another. There are automated metros running in many cities around the world that are carrying millions of passengers every day with no driver in the vehicle, fully automated, but they're in protected rights of way. And when you've got unprotected rights of way, you have unpredictable behaviors by other road users that make life really complicated. And that's the part that makes it so difficult, particularly when you have to get to the point that you have less frequent and less severe crashes than we have today with human driving.
Yeah, yeah. And we have, as human drivers, we have tail cases that we encounter for sure, and just, well, a whole range of things, obviously, that lead to accidents. I guess, in your opinion, like, who determines and when do we determine that sort of critical point when automated vehicles are as safe or safer than human drivers? Because if there's ever an accident with an automated vehicle at this point, it gets coverage, right? It gets uh, covered, even if it was a complex situation that may have been unavoidable, right? In some cases, it's
Yep.
avoidable, but if it's unavoidable, I mean, who will make that determination at that point that we've reached the the Goldilocks point of it just
Yeah.
being right and we're ready to move forward?
I don't think there's any particular individual who's going to make that decision. That's a broader societal decision, and that decision will be different in different places.
Yeah.
Different countries, different societies have different tolerance for risk. So, places that have a higher risk tolerance will find it acceptable earlier than places that have lower risk tolerance. Um, but we also have to be conscious that a lot of this is difference between perception and reality. Um, and when dealing with rare events and hazards to health and safety of humans, people don't always have realistic perceptions. Um, and I use the example of people who are afraid of flying. Sometimes I'll be on an airplane next to somebody who's a, a fearful flyer, and I always have to explain to them the most dangerous part of your trip was the drive from home to the airport. Once you got on the airplane, you're a whole lot safer than you are anytime you're in a car. But that doesn't mean that people perceive that they're safer when they're in the airplane than when they're in the car. So there's a difference between perception and reality. Um, and of course, everybody thinks they're a better than average driver. They can't all be better than average drivers. And typically, the ones who have the highest self image about their driving capability are among the worst drivers. So, matching reality and perceptions is a real challenge.
Yeah. Yeah. And I guess, test time and having a lot of test time behind these systems is a critical factor. But there's also so much change with, you have software that changes, and if you make a simple change, the question becomes, like, do you have to start from, how do you start the clock over from how much test time you
Yeah.
put into the vehicle? I mean, what are your
Yeah,
thoughts on that?
that's a really challenging question that I don't think anybody has a good answer for yet, because we know that when you make a software change, you can have some unintended consequences. So, 90% of the time it may not be a problem, but 10% of the time, well, you broke something else when you fixed the first problem. And how do you know that you didn't break something else when you made that fix? And
Yeah.
that's a challenge for regulators everywhere in trying to identify what's the threshold when you have to go back and recertify a system. Um, so I think that's an open question that's still going to need a lot of attention.
Yeah, and there's a dance between, depending on the application, there's a dance between, am I braking too hard or am I not braking enough? Like in a cargo application, you can brake maybe as hard as you want, right? And but in a but in an automotive or robotaxi situation, it might be a little different. You might tolerate harsher braking, but in a transit application with a bus, if you have people standing up or just not being buckled into seats, you don't want to have as much harsh braking, right? And that's a constant trade-off with autonomy. When people
Yeah.
tweak these systems.
Yeah, and that is something people have to deal with all the time. I would say, though, even in the cargo application, as hard as possible is not necessarily the best thing if you're going to cause a secondary crash with somebody behind you. So,
True. Yeah.
so maximum braking isn't even for sure the best thing to do. Uh, and everybody has to deal with that whole risk assessment for each response to a fault condition. And that gets to one of the big challenges that comes up when people start talking about test scenarios. Um, I am not an advocate for test scenarios as the way of determining safety of systems. I think I've evolved over the years to concluding that really the best way of assessing the safety of the systems is reviewing the safety case. And both the developer and the operator. And we have to remember a lot of these are fleet operations, so the behavior of the fleet operator is also safety critical. It's not just the behavior of the software in the vehicle. But each of those entities needs to have a safety case, and that safety case needs to show what's the process they went through to assess all of the hazards they're going to be encountering, and how have they, first of all, identified the hazards, and then how have they gone about mitigating the risks associated with those hazards. Um, do they have a systematic process for assessing those risks and for mitigating the risks? So that would come into things like how hard do you brake under different circumstances when you maybe have a traffic incident ahead of you, or you may have a failure on board your vehicle. Do you have a good process for identifying those risks and for mitigating those risks? Do you have a proper safety management system so that when the system is being developed and when it's being operated, proper priority is being given to safety over, say, economic considerations? And if the developers have shown that they have a good safety case and a proper safety management system, then you've got a higher level of confidence that, okay, they're probably going to behave well under this new situation that they haven't encountered before. But if they don't have those things, then the likelihood that they're going to behave safely in a new situation is probably lower.
Yeah. Yeah. And it's interesting when I was in grad school, I actually studied my thesis topic was on safety critical railway systems and how to apply software. You know, it's an oxymoron, but how to make safe software. But but a book I read was from Nancy Levinson called Safeware, and I remember reading some of the case studies in the back where was one of the most interesting aspects of the book where she started to point out that like, and this was at the time, this is in the 1990s. I don't know if it's still the case that like something like 50% of these case studies that we were looking at all were rooted in issues that occurred during the sort of requirement specification process. Like in that, and that even if you had sort of firewalled independent software teams working on something independently, that it could tie back to say the same a fault that sort of happened during the specification or requirements process, and then that led to some thinking about formal methods and all these things. How do you make a specification or a requirements document correct and complete? And I don't know if that's being considered in the world of autonomy today across industries or standards. But what are, any thoughts on that or
Well,
observations?
Uh, yeah, that's really critical. And actually, Nancy did some work with us in the earlier years of our PATH program in Berkeley and dealing with some of these safety questions. So that's part of what got me sensitized to the criticality of these safety issues. But there are no shortcuts. And that's where we run into the conflict with the Silicon Valley mentality of move fast and break things. And if you're developing a mobile phone app or a search engine or something else like that, well, it's not safety critical. So you can put it out to the customer for beta testing, even when you don't have all the details worked out. But when you're dealing with a safety critical system, you can't do that. You have to have a careful, methodical approach to dealing with all of these things. And that is the sort of thing that should be showing up in the thoroughness of the safety case and in the safety management system that each of the companies involved in this has. Have they given proper attention to those subtle issues? For example, incomplete specification. How have they made sure that their system spec is sufficiently complete, that they've dealt with just any of the foreseeable hazards that could arise?
Yeah. And I mean, presumably that's unending in some regards with respect to ground vehicles across different environments. I mean, the you know the cases of Cruise's event that they experienced. I guess it was last year with the
Two
person
two
who
years
was
ago now. Yeah.
2 years ago. Wow, yeah, time flies.
Yeah.
And then recently, just with Waymo, the vehicles that went into sort of an area where I guess it wasn't clear whether there were, I don't think there were people in the vehicles, but these vehicles were, some of them were like set on fire, and like, those are edge cases or situations that you'd be hard pressed to think about, I would think, in a specifications process. And you just kind of
Yeah.
have to start to build up a database, it seems, of like these situations, so that you can leverage that moving forward, and think about those situations.
Yeah, and you have to think about what are the unthinkables that might still happen. And I think the cruise crash in San Francisco is a really good example of something that I would guess nobody had in their test suite. Nobody had
Right.
in their training suite. The scenario in which a different vehicle hits the pedestrian, and then the pedestrian bounces off that vehicle and lands in the path of your vehicle in a location that's really hard to see. And now, of course, now that it happened and it got a lot of publicity, I'm sure it's in everybody's test suites and everybody's definition of potential hazards. But that's part of the learning process for the industry as a whole. And I think there is some progress in terms of industry sharing of some of this type of information. Now, the creation of the AV info share it enables some of the companies to start sharing the lessons learned on some of these safety challenges.
Yeah. So tell me about that AV Info Share. Who hosts that, and how is that kind of organized?
I don't know a lot about it, but it's a variety of major industry players, and MITRE Corporation serves as kind of the executive for that. And of course, they have the
I
experience
see.
of having done that in aviation. So the idea is to bring in some of the aviation experience in dealing with uh, hazardous situations and try to apply that in the road vehicle automation sphere. And I'm hoping we'll see some more information about that. They announced it about a year ago, and it's been getting underway, but there hasn't been a whole lot of public information available yet.
Yeah. Yeah. And it's always made me wonder, like, you know, there we might benefit from having a more open and accessible kind of database like that, where not just practitioners in the space can be submitting cases, but after some, of course, vetting and but like people who are thinking about this, who are now riding in these vehicles, riding in the Waymo vehicles and riding in other cars, and who could provide feedback that could be useful to industry, but of course that could be, and maybe leveraging AI to some extent to filter through the good comments and the bad comments.
Yeah. I'm not sure whether I trust AI on that. I think that's probably going to need a lot of human judgment about does this look like something real or something that's
Yeah.
not real. You don't want to start having to deal with things that are, let's say, physically unrealizable, but but things that actually could happen in practice. And we also have to be conscious in other parts of the world, the driving environments can be a whole lot more complicated and difficult than they are in what we have here in the U.S. Uh, having been in several parts of the developing world, you see the complexity of the traffic interactions, and say those places are going to have to wait a long time before they see automated driving because the complexity of their traffic environment greatly exceeds our complexity.
Yeah, and different tolerances of what's acceptable and what's not, right, across countries and just regions, you know.
Yes, but also just let's say how close together the different road users will get, within fractions of an inch, or sometimes even touching. And okay, they don't stop; they don't consider that a crash, but they'll just keep going. And how
Right.
do you deal with that when you've got an automated system that's trying to avoid hitting anything? Um, because there are other road users who may not mind hitting it.
Right, right. Interesting, interesting. Well, just kind of pivoting here for a moment, taking us back now to what the original vision for Path was when that was started. Be interested in what your sort of thoughts are and perspective is on that, and then the automated highway systems consortium and that demonstration.
Yeah.
I guess that was in the '90s. Is that right?
Yeah. The demonstration was in 1997. Pat started in 1986, and the it was sort of a broad concept of how can we apply information technology to make our transportation network work more effectively, with a particular emphasis on freeway driving, since we're so heavily dependent on freeway driving. But not just information technology, but also roadway electrification. So, one of the major elements when we started was dynamic recharging of battery electric vehicles um, by inductive power transfer from beneath the road surface. Um,
Wow.
that part of the work only lasted the first few years because we really ran into some significant technical obstacles that it was not possible to get the cost of the roadway unit down to a feasible level. It was just going to be too expensive to install that in the roadway, given the level of technology that was available at the time. And
Yeah.
now some of those technologies have improved since then so that it might be more feasible now than it was then. But so there was the roadway electrification element, then there was also a major element of automated driving, and also elements of providing improved traffic management and traveler information. So all these different pieces that now go under that umbrella of intelligent transportation systems. And we particularly emphasize the automated driving because of the potential for large impacts on highway capacity. How could we make more efficient use of that very expensive right of way that we have on freeways? So, could we get the vehicles driving closer together and safely? Uh, and closer together could mean narrower lanes for light duty vehicles, and closer together could mean shorter following distances. So when we started that, there were a lot of unknowns about how feasible are different elements of this. And for example, we didn't really know how accurately could you measure the position of a vehicle within a lane, and how accurately could you steer a vehicle automatically to keep it close to the lane center. Is it really practical that you could get to narrower lanes? So there's a whole set of research dealing with that, and we showed yes, indeed, you could steer very accurately if you have good measurements of where you are in the lane. Um, And then also a lot of work on improving vehicle following control, being able to measure the distance to other vehicles, being able to communicate among the vehicles to exchange information about location and speed and acceleration so that the vehicles can anticipate the movements of vehicles ahead of them, and then they can travel closer together. So
Interesting.
we did a lot of work on that, and then much of that got demonstrated in the National Automated Highway System Consortium demo in 1997. Um, uh, so we were at the point where we could show we could do very good steering control, we could do really accurate vehicle following control, but it wasn't really clear would people feel comfortable using this. So the 1997 demonstration was an opportunity to give demonstration rides to several thousand visitors who came to that demo. So, and the reactions of the visitors were extremely positive. So we did surveys of people who were riding in the vehicles, and the survey results were sort of off the chart on the positive end. Like almost everybody chose the highest rating in terms of their level of comfort with the way the systems were operating. So that was all very encouraging. Um, but then the Department of Transportation decided, well, this is going to take too long for this to get turned into something that would go out on in public use. So they directed their research funds elsewhere. And the the demonstration in 1997 um, represented about the first quarter of what was supposed to be done under the National Automated Highway System Consortium. And the other three quarters of the work never got done because the DOT decided to put their funding elsewhere.
Ah, interesting. So, and the sensing technology at that point, like for localization and then the following, were there like things in the ground
Yeah.
for like localization and yeah.
Okay. Well, so for lane positioning, so lateral positioning, we had permanent magnets embedded in the pavement, and they were
Okay.
at an interval of about 1 meter down the center of the lane. Um, and that made it possible to measure the lateral position of the vehicle to an accuracy of, if I recall, about a millimeter. So, with millimeter level accuracy
Wow.
on your lateral positioning, you can do very good steering control. Uh, and those magnets also were encoded. So each magnet, we had to install them. So we had a sequence of north and south pole being, in terms of which ones were up and down. So that was a binary code embedded in the sequence of magnets to indicate mileposts along the way. And then that referenced a map database of the road geometry. Um, so the vehicles would know if there's a curve up ahead, they know through the encoding that, okay, 50 meters from now, you've got a curve to the right of so many meters radius, and they could anticipate that before they actually got into the curve. Uh, then we also had vehicle to vehicle communication. Um, and I believe it was like I think it was 20 updates per second for each vehicle broadcasting what it was doing. So the vehicles in its vicinity would know what it was doing. And that made it possible to do a very close vehicle following with high accuracy, as well as having radar. We're using radar on the vehicles
Okay.
to do the ranging for each vehicle to the vehicle immediately ahead of it. Uh, and we did a lot of the testing at a gap of 4 meters between the vehicles while they were driving at 58 miles per hour. And Interesting. It was 58 miles per hour because there was a transmission shift point right above that, and we didn't want to be operating right around a transmission shift point. So again, we didn't have control of the transmission shifting. That was done by the automatic transmissions on the test vehicles. So we stayed just below the transmission shift point in order to avoid getting into transient disturbances associated with the different vehicles shift gears at different times along the way. And for the demonstration, I think we used 5.5 meters separation between the vehicles, although most of the testing was at 4 meters.
Wow. And how many vehicles were running in this demo?
That was an 8 vehicle platoon. Uh,
Okay.
so we had 8 vehicles. The run along the I-15 HOV lanes was about 7.5 miles, and we had multiple maneuvers embedded in that. So we had lane changing, so we could do lane change of the whole platoon. But then we also had one of the vehicles separate from the platoon, do a lane change, slow down. So it was like the second vehicle in the platoon would break away, would slow down to then rejoin the platoon at the back, so that we could show we could do automatic lane changing. We could do the cooperative maneuvering, so the vehicles were communicating with each other and do those different elements of highway driving. Now, this was all designed for use on a dedicated highway lane where it's not mixed with other traffic.
Right.
So we were doing it. We had an HOV facility. There's 2 lanes in the median of Interstate 15, so it was closed to other traffic, and that was a nice environment for being able to do those experiments. And the concept behind that is that you would do this automation in dedicated lanes. You would not try doing this in mixed traffic where you have to deal with the unpredictable behaviors of other drivers, but it would be restricted to vehicles that were equipped with the proper sensing and communication technology. So they're all following the same protocols.
Interesting. I mean, and the technology, I mean, the V2V, communications technology and the radar per vehicle isn't very expensive today, right? By today's
No, no, no.
measures, certainly compared to, the LiDAR and what have you that you see on some of these vehicles. But yeah,
Right.
it seems like it would be economical, maybe save for, I don't know how expensive the in-road infrastructure would be.
It's not very expensive at all. We actually did some estimates for installing that. It was what the way we were installing it, by the way, was very labor intensive. We didn't have an automated way of doing the installation because we were just doing it for that limited sort of highway. But as I recall, it cost about $10,000 per mile to do the installation. And if there was going to be a plan to do this on a larger scale, well, we would have had a robot doing the installation that could have done it a lot cheaper, because there were guys out there with jackhammers, putting the holes in the pavement and then manually inserting the magnets into the pavement. That could all have been done using a very simple robotic system. But again, there wasn't any reason to do that for a 7 mile installation.
Are you aware of any efforts today to kind of do something like this? With their HOV lanes, are there AV lanes kind of being contemplated where you might put something in the infrastructure for vehicles equipped with this technology
There,
or
there,
something like it?
there aren't right now. There have been a variety of plans over the years to do that have not come to fruition. There was actually quite a lot of work on this in Japan, and there were a variety of experiments that were done in Japan using actually much more expensive magnet installation than anything that we were doing. And there has been some work on, I think in Sweden more recently, on snowplow guidance using magnets embedded in the road, because if the road's covered with snow, the vision system isn't going to do you a whole lot of good in telling where you are relative to the roadway. But the magnetic technology isn't affected by snow or water or any of those other things.
Yeah.
Um, but right now, I'm not aware of any current activity.
I wasn't sure. I thought there was something up in Michigan, like Cavnew or something like that.
Yeah, but I think what they're doing on I-94 is basically having communication between the vehicles and the roadside.
I see.
I'm not sure whether there's any more infrastructure than just the communication devices. Uh,
I see.
uh, I it would it could certainly help if there's some reference markings added as well. But now with people doing a lot of the LiDAR point cloud mapping, that can also get to very high accuracy.
Right. Right.
So, so at least prior to LiDAR point cloud mapping, this was certainly the highest accuracy for lane positioning. It's a lot more accurate than vision recognition of lane markings.
Amazing. Amazing. And this was, almost 10 years before DARPA Grand Challenge
Uh,
version
yeah.
one. Or
Well, and actually, this would we started developing that back in 1990. So I mean, it was used for the demo in '97, but there was 7 or 8 years of development prior to that demo in '97.
right. So I guess following on from what you did with Path,
Yeah,
there was the cooperative adaptive cruise control. I think that had something to do with
yeah,
platooning, and
yeah.
I guess what was the deal with
Yeah,
that?
okay. Well, this is all work that we've been doing under the PATH program. So after we did the automated highway demo in '97, then and the federal government decided to go off in a different direction. Um, the state of California is still interested in the use of automation for trucks and for buses. So they supported some continuing work on truck platooning and bus platooning. And we did work, we had three trucks, heavy trucks equipped for automated driving. In this case, we weren't doing automatic steering, we were just doing automatic car following. So it was level one automation. Um, but driving the trucks really close together so we could reduce aerodynamic drag. And there was actually several projects dealing with that. Later on, we also did some of that work with the Department of Energy, um, and did some very detailed aerodynamic drag experiments in collaboration with Transport Canada on their test track near Montreal. Excuse me. And we made some very detailed measurements of the drag savings we could get with a three truck platoon, separate measurements for each truck in the platoon, and a wide variety of gaps. Going from 3 meter gap to like about an 80 meter gap, as I recall. So we did a variety of maneuvers with cut-in vehicles as well, so we could get a good sense of just how much fuel you'd be able to save on the heavy trucks when operating them in platoons. And there are potentially significant savings on all of the trucks in the platoon. The truck in the middle saves the most, but the first truck and the last truck also save some measurable amounts of fuel when they're operating at the closer spacings. Um, and then State of California was also interested in bus platooning, so we did a demonstration actually in 2003 with a three-bus platoon. In that case, they were fully automated, so we had automatic steering and automatic speed and spacing control with those, and that was also mixing different kinds of buses. So we had an articulated diesel-powered bus, and we had two single-unit CNG-powered buses. So the idea is, could we mix buses with different kinds of powertrains and with different dynamic characteristics and get them to work together well? And that turned out very well. Also, we gave a demonstration and gave rides to a bunch of visitors in 2003 on the automated buses, um, and that is something that actually looked like it had a good opportunity to get to an early deployment. But the question was where to do it, and we did get a field test going in Eugene, Oregon, on their busway with the automatic steering control of the buses and precision docking of the buses at the bus stations. So, with the precision docking, we could get the articulated bus to come up to the platform with a gap to the at the doors of on the order of an inch or so. And when you've got a really small gap like that, then it becomes easy to get wheelchairs rolling on and off. They don't have to deploy the ramps for wheelchairs, but people with wheelchairs can get on and off without any delay. And doing that with an articulated bus is actually pretty tricky because you've got to get both the front part of the bus and the back part of the bus lined up parallel with the platform. Uh, so that was kind of an interesting project. Again, in that case, there's level one automation that was only controlling the lateral control. The driver is controlling the speed of the bus. But it was a great workload reliever for the bus driver because the bus driver could then pay attention to the passengers and to people crossing in front and the cross traffic and didn't have to pay so much attention to accurately steering um, on a busway that had some pretty sharp, tricky curves in it. So,
Wow.
and one of the advantages for the bus operator was reduced tire wear because the human drivers who were driving those buses were tending to scuff the tires up against the curb on this rather narrow busway with sharp curves. And with the automatic steering, it stayed properly centered in the lane. There wasn't any scuffing of the tires against the curb. So um, that was one of those unexpected advantages that showed up because he was able to get around a problem that they were having with the normal bus drivers driving on the busway.
Wow.
So
And is that all using infrastructure, any
yeah, yeah,
infrastructure
yeah, yeah.
sensors, or was there something on board? Yeah.
Well, that was using it's both. I mean, that was using magnets embedded in the busway and the
Okay.
sensors on board the bus that would detect the magnets and do the signal processing on the magnetic fields and then generate the steering commands for the bus. So we had to retrofit the bus with a steering actuator uh, and and then a driver interface, so the driver could activate and deactivate the system. And of course, they had to have the sensors to detect the magnets that were buried in the busway. Uh, so we we did that on a bus for the transit agency in Oregon, and then there wasn't enough funding to go on. They wanted to equip all of their buses with that, but there wasn't any funding available to do that. And, and
Yeah.
that's an
Yeah.
example of difficulty of commercializing technology that worked really well, was ready to be commercialized, but there was no way of scaling it up to put it on buses because the market for transit buses is not very large. Uh,
Right. And the margins are tight, is my understanding, for the manufacture of such
yeah, the
vehicles.
margins are tight, but if you're going to industrialize this and get it to a cost that's reasonable for installing on a bus as a retrofit, it requires some upfront investment. And the problem is nobody could recoup that upfront investment based on the number of buses that they might be able to equip.
Right. Right. Interesting. I mean, all of this is so far ahead of the its time in terms of
Yeah.
like there's similar things happening today, right? With certainly with trucks. With I know there was a truck platooning company, Peloton, I think it
Yes.
was that
Yeah.
that had been doing something, and of course there's Aurora which is not really doing platooning, as far as I understand.
No, 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 they're
I think
not.
they're just doing
No, they're doing individual truck automation. They're not doing platooning.
Yeah, yeah.
But yeah, Peloton was doing platooning, and yeah, and then couldn't quite get to the stage of being able to go fully commercial. Um, and and we had a excuse me, we had a field test ready to go for truck platooning with a truck fleet that in the end we weren't able to do because there was some really low level challenges of integrating with the adaptive cruise control that was already equipped on the trucks. And this is a challenge of some very low level internal software issue that couldn't be resolved between the truck manufacturer and the supplier of the adaptive cruise control. Uh, and we spent a year trying to get that problem solved, and then basically there wasn't enough funding left after dealing with that problem to be able to do the field test. But we had a very elaborate field test ready to go with a truck fleet operator who was going to run a 3 truck platoon for a year on a run between Los Angeles and Texas, and we were going to have truck platooning running. Running a platoon every week back and forth on I-10, but again, the funding ran out before we were able to actually do the field test, and that would have generated a lot of data on the driver acceptance and the driver usage, the driver decisions. When do they want to use it? When do they not want to use it? This is not intended for use in high density urban traffic, but really when you're operating at full highway speed out on the open road. So drivers would engage it when they're out in the cross country operations, but they wouldn't be using it when going through the urban areas.
Interesting. And you you touched on the sort of the economic viability of highway trucking over maybe other applications of autonomy. Do you think that I mean, do you think there's some significant impediments still with large trucks on highways on without a human operator involved?
Well, it's the same impediment there is for the urban operations, only it's amplified because you've got a vehicle that is so much bigger, and that when something goes wrong, the results could be really catastrophic. So
Yeah.
I think there is a much stronger business case for doing it for long haul trucking. There are all sorts of reasons why that makes economic sense. But the big challenge is, can you get to the point that you can confidently remove the driver and have high enough confidence that regardless of what happens, nobody's going to get killed or injured.
Right, because this risk level, the severity is high
So,
in the event of an accident, comparatively speaking, presumably.
right, because the speed is high, and of course, you've got a huge mass involved, and you've got the
Yeah.
public perception as well. So,
Right.
um, so putting those all together, I mean that's a big challenge, and it looks like Aurora is getting very close there. I guess they pulled the driver out, and then their industry partner asked them to put the driver back in. So they're not quite driverless at this point.
Right. Right. Yeah. Yeah. Well, kind of touching on risk and appropriate use of technology, I guess. I know you're a controls. You have a deep controls background. I'm a controls, I guess, rooted in sort of controls, but also did some early work with neural networks and AI. I mean, how do you see the rise of AI and machine learning fitting into AV designs?
Yeah.
There's obviously been a lot of companies that are using it and push to use it. I mean, what are your thoughts on that
Yeah.
versus more deterministic approaches?
Yeah. I Coming out of control engineering, of course, I'm much more comfortable with the deterministic approach, and particularly when you have to deal with the safety assurance. How do you know that the system is going to behave correctly under various conditions? So I can see the advantage of using machine learning in some aspects of automation, like say image recognition, and some of the planning aspects of it. I am deeply skeptical of the end-to-end machine learning approach. I really don't see how that can ever get to the point that the safety could be assured when the entire thing end to end is a black box. So when it misbehaves, how do you figure out what you do to make it not misbehave? Uh,
Right.
Presumably, you use the biggest set of data you could get your hands on to train it, and now it still did something wrong. So where you're going to get the bigger set of data that's going to cause it to unlearn the bad thing it learned and get it to learn what it should be doing? You can't just go in and find the errant line of code and fix that line of code um, when you've got a total black box. And
Yeah.
that that part kind of spooks me.
Yeah. It's a matrix of unreadable numbers. Well, you can read them, but you wouldn't understand them. And there's also the regression when you fix something. How do you know you didn't break something, right? With the probabilistic methodology by which these networks are trained. Yeah.
Yes, yes. So, and that's why I can see it being used in more narrowly defined subsets of the automated driving function. But I also think for safety reasons, there are going to have to be all sorts of guardrails around everything that the vehicle does, and I think those are going to have to be rule based guardrails. I just can't imagine it being possible to do this without having rule based guardrails around the AI elements.
So why do you think? I guess there have been a lot of startups and a lot of companies, and of course, even I believe with Tesla, right? It's largely touted as progressing towards, if not fully, AI based neural net, deep learning based, right? Um, what what do you think is? I guess why do you think companies are doing that, and are they ignoring the fact that there needs to be some sort of verification and validation or certification at some point?
I I don't know whether they're ignoring it or whether they're just not giving it sufficient attention, or whether they think they
Yeah.
have a way around it. I mean, Tesla is sort of a special case because their boss seems to think they're on the brink of having artificial general intelligence, which I think is total folly. But that's what they seem to think, and then that's going to solve all the world's problems. But um, with the others, I don't know how they think they're going to get to the point that they can actually ensure safety.
Yeah. Well, I think we're in the same court on this, so I'm not sure there's anything I could say that would illuminate it. I was curious, and so I mean, agree with you like 100%. And being someone who's spent a lot of time doing work with neural networks and likes them for their utility and other applications, yeah, could never wrap my head around how do you verify and validate this for safety critical applications at scale.
Yeah, and I don't know. I see all the predictions that they make and say, well, I'm not. I wouldn't put any money on that. Um, uh, look, Musk claimed 10 years ago that automated driving on highways was a solved problem already, and I think that was like 6 months before their first release of their so-called autopilot, and you know, it it's still not a fully solved problem.
Yeah. Yeah, and again, even if miles and test time is sort of the supposed answer, the question of, well, what happens when you change one thing? You know, do you start all over? And how do you regression test a change to a neural network when it's you don't know what is really changed? You know.
Uh, yeah, this is this is a big challenge, and part of it, I think, is just the term AI now has so much weight associated with it, uh, that um, people aren't always thinking rationally about it because it's
Right,
become so
right.
fashionable.
Yeah, if you put LLM on your pitch deck, you're gonna raise some money.
Yeah,
Uh,
even though we're not talking about things that deal with language.
right. Interesting. And also SLAM, right? Simultaneous localization and mapping is something that, indoor robotics leveraged where you could map an environment with like LiDAR and sensors and know where things are and then have the vehicle localize where it is based on that. But what are your thoughts on SLAM? Maybe at some leverage neural networks, right, is part of this. But what are your thoughts on SLAM for autonomous vehicles and its effectiveness and or
Well,
pitfalls?
well, in a way, that's behind what a lot of the companies are doing with their point cloud maps. So, but they're not using only that. They're combining that with the data that they get from the sensors to detect all the other road users, which they have to in order to avoid colliding with those other road users. So certainly you can use the SLAM for your basic localization to know where you are relative to the fixed infrastructure elements, but you also need to know what all the other road users are doing, where they are, and how they're moving. So um, that I think it's a combination of those technologies. Just like I think in order to get to level four automation, you've got to have cameras and lidars and radars and precise positioning. And if you don't have all of those, I don't think you've got level four, um, because now you're too vulnerable to a failure of any one of those elements.
Yeah, yeah. And I know of one SLAM. I guess it depends on how you use SLAM and the methods by which you verify your map. Because I know there was an application where SLAM was used in the winter, and it would localize, kind of use the trees as reference points. And then the summer came along, and there was leaves and branches, and your ability to now find these landmarks in the environment becomes compromised.
Mm-hmm.
Not to even speak of what could happen what happens in urban environments where you have occluded surfaces and what have you due to just the environment in which you're
Yeah.
operating.
Well, I think that's part of why they have to drive multiple times through any of those environments to collect the data under a wide range of conditions. Obviously, you're going to have parked vehicles, and you can be driving next to a truck that occludes your view of anything on that side of your vehicle. Um, so yeah, people need to go through and collect the data under a wide variety of conditions. And you have to, depending on foliage, then they need it at different times a year. Uh,
Yeah.
and it gets more complicated when you're in locations in which they don't maintain the roadside shrubbery so well, and the roadside shrubbery starts blocking signs and doing other things like that.
Yeah. So, um, kind of pivoting a little bit towards just traffic systems. I know you did some work with probe vehicles and traffic systems. There was I guess J2735, I think was what I'm looking in my notes. And I was wondering about your research studying how what the potential is for traffic systems to become smarter, not just via connected vehicles, but was there any leveraging of sensors mounted in the environment to like LiDAR in the environment to give information to these connected vehicles as well?
Well, we did a little bit of work on that for intersection collision warnings, and this is
Hmm.
probably 20 years ago or so. Um, the idea is to have a cooperative system for intersection collision warnings, because at intersections you've got occluded views. You may have occlusion because of buildings that are near the corners, so you can't see traffic that's approaching on a cross street, or your view of other vehicles may be occluded by other vehicles in the environment, like big trucks that may be occluding your view of other vehicles. So if you've got sensors on the infrastructure and in the right locations and the right number of sensors, then you can get a more complete view of what's going on in the intersection and can provide warnings. Again, we weren't trying to do automated driving through intersections, but this was more for purposes of being able to give a warning to a driver. Um, for example, unprotected left turns are often very challenging. Drivers have a hard time judging the speed of oncoming vehicles when they're trying to make a left turn. So if we can give them um, better information about the gap that's available to make that turn, then that should improve safety. And we did some experiments with that. We have a small test intersection at our test facility. We actually staged some experiments with what are called the left turn across path opposite direction conflict. So you're trying to make a left turn and there's an oncoming vehicle and in the opposite direction. How well do drivers judge those gaps, and could we give them a warning system that would uh, make it less likely they're going to try to turn in a gap that's not sufficient?
Yeah, yeah. And I guess, I mean, then with these, I mean, communications networks, when I think of fail safety, I think of a lot. I guess I think of kind of sort of railway based fail safety, where everything is kind of like localized, and you can sort of, even quantify the safety of the system to some extent. But with communication networks, that's that's a little more difficult, right? Like, how do you know, I mean, if you're reliant on something coming from a device over a communications network and it doesn't
Yeah.
get to you,
Oh, yeah.
you know
And the concept in this case was not that you would be reliant on it, but it would be supplementary information.
supplementary, yeah.
It's a driver assistance. It's not a replacement for the driver, and so the um, so the absence of a warning doesn't mean it's safe, but um, if it's unsafe and the system is working, you're going to get the warning, and then that will presumably deter you from making that unsafe turn.
Right. There was DSRC as a communications standard for V to V and V to I. Now there's like this shift to C-V2X as the underlying, I guess, protocol behind some of this technology, or methodology. Do you see that becoming more widely adopted in the near future? Those standards, or do you still see impediments? Like, because DSRC, there was a lot of hope there, but then it kind of was sunset in favor of this new standard, and it's not. I'm not quite clear as to where all the vendors are lining up with these standards, if there's alignment yet.
And it's a mess. It's a mess because we had a variety of people in the wireless industry who were eager to kill DSRC, and they worked all the political angles to kill it, and it was still better than the alternatives that we've been offered, and but again, it's really distressing to see the industry politics that went into that. Um,
Mm,
uh, because a company that supplies the chips earns 10 times the commission on a chip for a 5G system than they would earn on a DSRC chip. Um, so they can make a lot more money that way.
I
And
see.
um, and that's basically what wind up wound up driving this. So, and the other thing is in order to do that in a way that was really going to contribute significantly to safety, it was going to have to be on all the vehicles. So that was going to depend on a government mandate for new vehicles to be equipped with the wireless. And in the current environment, I'm not expecting NHTSA to be issuing new mandates for anybody to do anything, at least not for the next
Hmm.
4 years.
So I guess what's the holdup for CV2X becoming more widely adopted then, I guess?
Well, why would anybody do it? What benefit does the user get unless it's something that's required to go on all the vehicles?
Yeah, I guess, I mean, certainly enhanced, why do people want ADAS? Why do people want, I mean, to have a safer trip, right? I mean,
Right, but there's the network effect here, where you only get the benefit when you've got a large fraction of the other vehicles equipped, because you're dependent on getting the information from those other vehicles. That's why it needed to have the mandate uh, that you get it throughout the fleet of vehicles.
right, right.
Right.
Are there any way, I guess this goes back to like the equivalent of HOV lanes or things like that. Like if you have this equipment, you could travel in a special lane and confer some
Yeah,
advantages.
and I think that's sort of the CAVNU approach with the lane that they're setting up. I guess between Detroit and Ann Arbor, the idea is somehow you'd get a better trip if you're equipped and you use that lane. Um, but um, the problem is how to convince people to pay for something that is where the benefit is in avoiding a crash that they don't think they're going to get into in the first place.
Right. Or like, I guess, commercial operators of trucks and things like that. If they had that technology, it would be
If,
a marginal additional cost. Yeah.
right, if they can see the direct benefit that they get, but it's back to, is it associated with access to particular infrastructure rather than is it based on getting data from other vehicles that the owners may or may not decide to equip with that communication technology. So, um, so I think
Right.
we've lost a lot on the V2V aspect of that by not getting to the point of having the mandate for that communication to go on all the new vehicles.
Yeah.
And
Yeah, and having worked with those a little bit, like certain message formats, like spat messages and what have you, even across there were some inconsistencies even across vendor implementations a little bit that didn't quite shake out.
yeah, well, okay, and that's something that yeah would have had to shake out if this was really going to be
Right.
commercialized on a large scale. Um, but yeah, I think we've had a setback there. Now, maybe when they get to the more, I guess I'd say the more advanced versions of 5G cellular or 6G cellular, then that might become the mechanism for doing this. But um, and I think that's why the cellular V2X was put out there as a stalking horse for these other cellular implementations, uh, so that people wouldn't get the DSRC embedded, because then the
Interesting.
cellular operators then get a revenue stream too.
Right, right.
So
Well, what is next for policy standards, and the like ISO standards, SAE, what you're doing with the TRB and those committees? What frameworks are going to be guiding us here in the near future? And
well, the one that's actually in ballot right now is the update of the J3016 definitions document. So that's a joint ISO SAE activity right now, and we're in the ballot. There are a bunch of updates to that are um, in ballot. There will be some new terminology there to cover things that have come up since the last update. Uh, no change in terms of the classifications, but change to the names of the classes, because the verbal names never really provided very good description of what they were. So there are some slightly longer names that are going to be offered for each of the levels of automation. And then there's some more terms that are defined. Um, and um, I'm just trying to think of other things. On the ISO side, there is a standard that I think it's going from DIS to international standard for remote support for um, low speed automated driving vehicles. So that's basically for the shuttle type vehicles that operate without a driver on board. They still need remote support, and there is a standard for remote support functions for those that is working its way through the ballot right now. That was that includes both remote assistance and some remote driving. The remote driving part of it was very controversial, and a lot of concerns about what speed can you actually accept for automated driving. I'm sorry, remote driving of a vehicle. And we finally settled on 6 kilometer per hour maximum speed for doing remote driving. Um, so I know there are people who want to do it faster than that, but a lot of us were very uncomfortable with the notion of doing it at anything much faster than a walking pace.
Right. Right. Yeah. I mean, I guess is that just due to communications latency and what have you?
It's partly communication latency, but it's also the limited perception of that remote person. Um, when you consider how realistic an image do they really have of the driving environment, and in particular, are they going to be able to detect a pedestrian who pops out from between parked cars early enough that they can actually avoid hitting a pedestrian? And
Right.
that's sort of a primary concern in keeping this down at a walking pace.
Yeah.
Uh,
Is there are there any standards? Sort of. I know there are some standards, but can you point to some of the activities to define like operational design domain
yeah,
characteristics and
right.
like how to classify those?
Yeah, well, and actually, that's the J3259, which is working its way through the ORAD committee right now, is not yet ready for ballot, but that has quite a complete taxonomy of ODD characteristics and some guidance on how to use it. So um, hopefully that'll be getting out maybe later this year. There is an
Hmm.
ISO standard on that 34503, which I am not very enthusiastic about. I think it's not a very well structured taxonomy for ODD attributes. Uh, so hopefully, when the 3259 gets published, then we'll have a more complete and a more orderly taxonomy of ODD attributes.
Interesting. And will that cover like not just urban environments, but even off road, or is it just all on? I guess it's the on road
Yeah,
committee. So
it's the on-road committee,
yeah,
so it's all for on-road operations.
right.
But certainly
I
urban
see.
and rural, anything you might encounter on road, um, and and that will have some guidance about how to define the ODD. The other thing I should mention in the J3016, we have some new terms that are related to ODD to cover things that have been misnamed as ODD. And for example, one of those is expected operating conditions. What are the conditions that you are expecting to encounter on your current trip? Or what are the operating conditions you might be expected to encounter over the lifetime, the useful lifetime of a system? Um, so those sometimes get called ODD, but they're not ODD. And so we realize we need a different name for them. So those will be called the expected operating conditions. Um, and then let's say a public agency might say, well, in order for a vehicle to operate within our jurisdiction, it needs to be at least able to handle these kind of conditions. So that is now being called a required minimum operating conditions. So that would be something that a public agency might want to specify, but it's not the ODD because the ODD can only really be defined by the developer of the system.
Right. Interesting. No, that's great. I mean, that's been a classic, as I'm sure everyone knows, a disconnect between suppliers of AVs and the end users or the customers, right? Is to understand those differences better.
Right. So that's why we had to create some new terms to try to make those distinctions. Um,
Yeah.
and there's another one which I'm forgetting right now. There's a third new term that also relates to ODD. But the idea is that those now need to be used together with each other. Um,
Interesting. And one of the task forces that I um, helped, I guess, start when I was involved with the SAE committee was the verification and validation task force. And there were a lot of, this was a while ago, there were a lot of impediments early to sort of advancing that. Any breakthroughs in that area
yeah, yeah,
that we're seeing?
yeah. There is I'm I'm forgetting the name of it right now, but basically a set of assessment metrics that has just been balloted successfully. So that should be published very soon. So that's the
Oh,
first
excellent.
crack at some metrics for assessing the the safety of a driving automation system. And yeah, that we went through a lot of iterations on that. Uh, that that's very challenging.
Yeah, yeah. I know it's a well, it's a consortium of different folks from different areas, and they're automakers and I guess have folks have developed their different techniques over the years, and wouldn't want to be sort of precluded from participating in the market if one technique, I guess, won out over another.
Right. Yeah. Although this isn't even so much related to techniques, but it was more about what would you actually be able to measure that would give you an indication of the relative safety of the different systems, and how much of that can you express in terms of threshold values, whether you are above or below a threshold versus actually a direct measurement of a particular output. So there was lots of back and
I
forth on
see.
that. So do
So
you put it in a pass-fail mode, or do you put it in sort of an analog scale mode?
I see. So there's no specification of, thou shalt have dual redundant steering or something to that effect.
No, it's not at that level. It's more like a measures of the behavior of the system, not
Right.
something associated with the design of the system.
Yeah. Do you see anything like that kind of emerging in the somewhat distant future, like kind of requirements around redundancy or diverse redundancy or of some sort?
No, because there's so many different ways of designing the systems, and I suspect that would be very hard to standardize
Yeah.
that. Um, yeah, I don't I don't see that coming.
Right. Yeah, I mean, I wonder. I think about like with a fully driverless system or a driverless, like the driverless truck or something versus a low speed vehicle. Maybe your standards are different, but would what should redundant steering be required? I mean, a lot of them would be using that, but because if it gives way, that's a single point of failure that's catastrophic.
Yeah, but I think things like that would be handled more through the process-oriented standards, like the functional safety and SOTIF. Um,
I see.
I think that's probably going to be the way of dealing with those, where you uh, assess the risk of something bad happening and then try to show how you've minimized the consequences of that bad thing happening.
Right, right. Well, this is all so fascinating. I guess just kind of one or two maybe last reflective questions. I mean, you've worked at this intersection of tech and policy and research for decades. You've seen the industry from its very early stages to maybe you still consider it in its adolescent stage right now. I don't know where you see it,
I,
but
I,
what's
I
your
see it somewhere between childhood and adolescence.
okay? Wow. All right. So you don't think Jensen Huang from NVIDIA, the CEO, just said this is the decade for AVs and robotics. Do you agree with that? You think it's going to go from adolescence to adulthood in this decade, or you think it's a couple more decades?
I think it's going to be further off than that. Um, and I think there are some issues of how to scale this. Um, and use the example of the automated ride hailing that Waymo is rolling out right now. Each time they go into another city, there's a significant upfront investment required in collecting the data, learning not just the physical infrastructure, but all of the local driving protocols, um, setting up the remote support functions, all of the other functions that have to be done when there's no driver in the vehicle for servicing the vehicles, providing the remote assistance. There's a lot of investment required each time one takes this into a new environment. And that's expensive. And
Mhm.
I think this is going to be a fleet operated function for the foreseeable future because I don't see the remote support functions becoming unnecessary. I think those remote support functions are going to be necessary for the foreseeable future. And that also
Yeah.
means I don't envision it in private personal vehicles. I don't see how that's going to be possible when you think about considerations of maintenance and all of this sophisticated technology on the vehicles that has to be properly maintained in order to work according to spec. Um, we know that private individuals don't maintain their vehicles the way they're supposed to right now, and they can get away with it with the functions that are on vehicles today. But if you're going to get to level 4 driving automation, the maintenance is going to be critical. And and I think those remote support functions are also going to be critical to deal with the corner cases because the corner cases are inevitable. The corner cases will still be corner cases a decade from now. They'll be different from the corner cases today, but there's still going to be corner cases coming up a decade from now. And there has to be a way of handling them safely.
I couldn't agree more. I think we see eye to eye on that. I mean, I think, the robotaxi application, even to me, is out there, and as is the, but other applications, maybe like controlled transit loops and or mining applications, some of
Oh,
the off-road
yeah.
agricultural,
Oh,
certainly sooner.
oh, yeah, but those are limited size numbers of vehicles. Then that's not
Right.
tens of millions of vehicles. So
That's right.
that's not what Jensen Huang is envisioning, and I don't think he's right.
Well, with that, any parting advice for a young engineer or founder who's getting
Okay.
into the space as to where they should focus?
Um, I would normally say safety, safety, and safety. And there'll be plenty to do. You won't run out of things to deal with. I remember I guess it was about 10 years ago when Waymo first gave the ride to the blind guy that they publicized so much. Uh, I had a postdoc who said, well, it looks like all the problems are solved now. I ought to go into something else. And I said, no, 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 no. Don't worry about that. You're a young guy. You're going to be able to spend your entire career working on this, and you still won't run out of problems to solve. So, no, and that's what I would still tell young engineers today. There's lots to work on here, and you won't run out of challenges probably through your entire career.
Well, that's great advice, and from someone who's been involved in the field for so many years, appreciate everything you've done and are continue to do. So, thank you for taking the time today to talk about all this. This is fascinating to me, and I'm sure everybody
Okay.
will be tuning in. So,
All right.
thank you so
Yeah.
much,
Well,
Steve.
thanks for inviting me. It's good talking with you.
Wonderful talking with you again. Thank
Okay.
you.
All right. Bye.
I hope you enjoyed the show Driven with me, Paul Perrone, your host. Don't forget to check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. Thank you for listening in. See you soon.